Hello, everybody. My name is Matias Katz. I'm from Argentina. English is not my first language, and it's not your first language. So if you don't understand something I say, so just say and I will repeat. And I know that I am the only one keeping you away from food, so I'm going to make it quick. I'm going to talk about X11. Who here knows what X11 is? I'm not talking about the protocol. I'm talking about the software, the X Windows Manager from a lot of operating systems. Who uses it every day? OK. So I was playing around with it, and it all came from an idea that I had back in 1995. First off, I'm going to invite you to a conference I organized in Argentina. It's at the end of November in Buenos Aires. The CFP is not open yet. It will be in a couple of weeks. I have a couple of T-shirts here to give away. I have a couple of questions to ask you during the conference, and the person who gives the best answer will get a T-shirt. And the CFP will open in a couple of weeks, so you're all invited to come. So I had an idea back in 1995, and I was watching a lot of Hollywood movies, and the main idea, the main doubt that I had was, what is the worst moment or the most vulnerable moment for our computers? Who here has their computer disk encrypted? OK, a lot. OK. So when you have your computer, if the computer is turned off, you're safe, because if someone steals your computer, it's encrypted, so that's it. So what happens when the computer is on? Who is guarding your information when the computer is on? I'm actually asking you, what is keeping an intruder from getting into your information when your computer is turned on? OK, we have a lot of things like the operating system. We have the encrypted volume and the software that's managing it. Call it TrueCrypt, LBA, whatever. And then that's it. That's the only problem we have. What happens when we turn on our computer, we put the encryption key in our software, and then we start using the computer, and then we lock it to go to the bathroom or whatever. What is the only main thing that is protecting anyone from accessing your encrypted but already decrypted temporarily information on your computer? OK, we have the upper level of the operating system, which is the GUI and the access to our session. We have a password-protected session or whatever. Then we have the software running on the background. We are not going to close the encryption every time we go to the bathroom. Someone does that? Does someone here close the session, the encrypted session, each time they log the computer, even if it's for 5 minutes? OK. Some people do. But most of us don't. I don't. So when I have my computer turned on and I have to go away for a minute or two, I just lock it. And that's it. So basically, the most vulnerable point in our whole system is when the computer is locked, but already logged in, and we have our password, our encryption password, put it into our session, and that's it. So the most vulnerable situation in which we can get an intruder to access our information is when the computer is unlocked. If someone right now grabs me and someone else takes my computer, which is unlocked, I'm screwed. Because I have already decrypted my disk to access my presentation or whatever, and then you can take my computer, the operating system is unlocked, and that's it. So after watching a lot of movies that people do that, I started wondering, how can I lock a computer using hardware? Well, we can put a condition on the computer that if certain hardware exists on the computer will stay unlocked. But if I take that hardware out, the computer will lock. Basic principle. So I turned it down into 2 steps. Of course, in 1995, I was only 10, so I didn't do anything. But a couple of years later, actually last year, I started again with this research, and I basically put it down to 2 steps. One is to find a way to lock the computer, and the other one is find a way to read a device that will actually do that game of having it on and off. And I came back to the most simple hardware you can connect to a computer, which is a USB device. Yeah, so if I have this USB device plugged in, the computer will stay locked, unless, of course, that I lock it. But if I take this device off the computer will lock even if I'm on it. So I did it in 2 ways. There's step number 1, to find how to read a device. Do we go for the file system? And I didn't like that because the file system depends on how the operating system is handling it. You cannot check if the SDB device is connected because anyone can connect another flash drive, and if this one is not connected, then the next one that's going to be assigned by the operating system is going to be SDB. So that cannot work. So I went for the unique identifier, which is an identification unique to each piece of hardware, almost. So what I did was quite simple. In Linux, you have, of course, in Linux, everything is a file, whatever, anything, everything is represented in a file, so you can access pretty much anything you want by accessing a single piece of plain text file. So when you connect a piece of USB drive or whatever, you get an enrollment into this /dev/dix/byid like a folder. It's not a folder, but it's inside the identifier. So the only thing that I should do is check the presence of my unique identifier inside that string and check every 0.1 seconds. That would be enough. So it's pretty easy. So what about the second step? What about the trigger the lock of the computer? And I thought about dbus. Who here knows about dbus? Awesome. Little people. Awesome. Then I can explain. dbus is an IPC software, inter-process communication software. It provides communication between the operating system and different applications, and also between application to application. It's like the RPC in Windows, but it's much better. Also, you can install dbus on Windows. So dbus handles software, handles hardware, handles changes, handles environment changes. Each time you connect to a Wi-Fi, who here uses GNOME? GNOME on Linux or KDE or XDM? Okay, each time you connect to your Wi-Fi, each time you change your network configuration, each time you lower the volume or mute or pause or whatever, dbus is handling that. It has an upper level of software which is connected to the GUI and to you, and then between that software and the kernel, it's dbus. The GUI talks to dbus and says, hey, I want to do this, and then the dbus talks to the kernel. So it has complete dominance over the computer. In order to do this, of course, it has to run with privileges. It speaks directly to the kernel. It doesn't have to ask for authorizations from anyone. Anything that you do, anything, goes to dbus, and dbus says it's OK. For instance, if it wasn't for dbus, you will never be able to connect to a Wi-Fi if you weren't root, because you need higher level to change the configuration of the network adapter. So dbus does that for you. You cannot turn off your computer if you weren't root. When you do it, when you go to the corner and hit shut down, you're talking to dbus. And of course, it's available in almost all X display managers. So I chose to use dbus because it had a cute, fun way of playing with this. I'm going to show you a small demo. First off, I'm going to show you a couple of things that you can do with dbus. You can do printing. You can do remote control, you can change the daemon, you can change the sound, you can change a lot of information. You cannot manually disable certain parts of dbus. It comes as a whole. Either you have it or you don't. And if you don't have dbus, you will feel it because you won't be able to use all your main features that you're used to use in your computer, like muting the sound or whatever. So you have a lot of information. And all this is handled by dbus. So I have, let's list. This is all the devices that I have connected on my computer right now, which of course are all the partitions from my SDA or my main hard drive on my computer. And I'm going to connect this and see the difference, the change. Just going to give the OS a second to read it. Can you read OK? Yeah? Now I'm going to run it. And now it finds the difference that has SDB and down the SDB1, which is the only partition I have on my device. So I'm going to list now the identifier files that the operating system has created for me to access my device. So I'm going to go here, and I have a lot of information. All this comes from my devices. For instance, the SDA1 is a Toshiba, blah, 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 and this is part of the serial number, and this is the unique identifier for my own disk. If you have the same disk, you will have a different unique identifier, supposedly. Like there's not MAC addresses being repeated. We will never know that, but let's try to believe that it's like that. So we have the unique identifier, and I'm going to find the unique identifier for my flash drive. I don't have the UUID because this hardware is not providing it, but I have the by ID, which is pretty much OK. If you want to do this right, you should get a piece of hardware that provides this line. You can buy a $2 or €2 flash drive, and that's it. So I'm going to use this. So I have, this is from all demos. So I'm going to call, this is Python, and it's going to call the dbus session bus object. And I'm going to grab the org.genome.screensaver because I'm using genome. But of course, you can use KDE. Can you see the red? Yeah. You can use KDE or you can use free desktop. Whatever you use is the same child of the same object. Of course, I'm going to tamper with the screensaver, playing with how the dbus handles the screensaver. Each time you lock the computer, the actual engine that is locking the computer is dbus. So I'm going to go ahead and say file equals and all this. So it's pretty simple. If it doesn't exist, screensaver.lock. That's it. That's it. That's how the object works. If it's not working, if it's not present, that file and time sleep 0.1. So I'm going to try it. So the computer, well, I'm going to put that. So the computer is working. I'm doing everything right. And when I take my USB out, it's going to lock the computer. It's quite simple. Even if I put the password, it's going to lock, but it's going to unlock, but it's going to relock in less than a second because it's checking constantly. So if I have this tied to my wrist and I'm in a dangerous place outside on the street, whatever, I have this with me at all times. And if I'm giving the talk and someone grabs me from behind and someone takes my computer and runs off, the computer will lock. The USB will pop and the computer will lock. And that's it. And I was very happy that I was able to fulfill my 1995 10-year-old fantasy. And now you can all do it. Pretty easy. Of course, you can do a lot of other things. You can sound an alarm. You can email you some information. You can start the webcam recording, and streaming. You can get information from the attacker or the one who stole your computer. You can power off. You can delete the private keys. You can shred the entire disk. You can do whatever you want. You can encrypt certain information that you have right now. Even if your device is decrypted, you can re-encrypt using another method without a password that you have on the computer with maybe a private key, whatever, encrypt certain files that even if they access the drive, they won't be able to access those specific files. So you can do a lot of things. It depends on your imagination. But the basic stuff is to call the bus, tell them to lock the computer if something happens, and then do something else. That's it. But then I thought, can I unlock the computer using the same method? Can I play around with the computer and manipulate myself when and where and how the computer will unlock, no matter what the user says? So I thought about generating a backdoor. Of course, unlocking a computer always has two steps. Like locking it, we have to find a way to unlock a computer, some way, somehow, and then to set a trigger to that unlock. So we have control. Like a backdoor works, you all know how a backdoor works. A backdoor is dormant, it's on the background, running but not making any noise. And then when the attacker sends a specific trigger that is preset on the backdoor, the backdoor will do what the attacker wants. And for a backdoor to be a good one, it has to have small traces, so it doesn't have to make a lot of noise on memory, on the CPU, on the disk, doesn't have to have much files, and it has to have a stealth trigger, a trigger that is not very noisy, that is not fireworks, something that is inconspicuous or something like that. So, unlocking a computer leaving small traces. Do we use binaries? No, I don't like it. Do we use rootkits? No, I don't like it. I want to be more creative. Do we use operating system features? Hell yeah. Why not? Why use binaries when you can use OS features that are already inside a computer? Why care about rootkitting a computer and leaving a trace or having my hash checked on the start by a integrity checker or whatever if I can use operating system features and be done with it? So of course, I chose dbus again. dbus has the option to unlock the computer no matter what. Yes, that's true. You can use dbus to unlock the computer when and where you want, no matter if the password is being set. No matter if the user puts the password or not, you can unlock it. So let's go to the second part, stealth trigger. In order to have a good stealth trigger, we have to be able to not alert the antivirus. Of course, we have to be able to execute it without suspicion. And we have to be able to have that trigger available in all computers. It doesn't work, well, it does work, but it's better if I have a trigger that works on PCs, on Macs, in a 1985 computer, in a 2-month-old computer, whatever you have, even on cell phone, the better. The more computers I can put into the circle of infected or vulnerable hardware, the better. So I can put it on one category. So then I thought, keystrokes, of course not. Antivirus capture keystrokes like that. Hey, you have a keylogger, blah, 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 blah. Open port? No. It's very easy for an antivirus or an IDS to check if you have an open port that shouldn't be open. And it's very, very easy for the user to close it with a few strokes and like 5 seconds. So I didn't like that. And remember that I'm trying to do this as nice as possible, like a piece of art. I don't want binaries, and I don't want keystrokes. I want something different, something to be nice and also to work. And I went with hardware because I had such much experience with hardware, working with the previous project, and I said, okay, let's do it. So, a stealth hardware trigger. We will not use any software part. We will not use keystrokes. We will not use a network connection. We will not use anything related to software. We will use 100% hardware trigger. So, to use a hardware trigger, the hardware change, the invocation of the hardware change, has to be responsive when the computer is locked. And that is not very common. There aren't many hardware changes that respond when the computer is locked. Also, the operating system must not interfere. We cannot wait for the authorization of the operating system, because that way we can alert an engine or something that is working with the operating system, and it might trigger an antivirus or an IDS or whatever. So we have to be able to respond while locked, and the operating system has to obey no matter what, without knowing or without authorizing any type of action. And the last, cannot be disruptive. And that one is important because it pretty much deleted all the other options that I had thought so far. So, question for you for the first t-shirt. What kind of hardware triggers comply with all these three? It has to respond while locked. It doesn't have to care what the operating system says about that. And it cannot be disruptive. That's a question for you. What? The mouse? Keyboard? Again, if we use mouse or keyboard, you can be triggered by the antivirus. Remember that. The basic stuff about a backdoor is that an antivirus is constantly looking at that. So if we put Control-Alt, backspace, Enter, an antivirus might catch that. So no keyboard. Screen. Good. Who said that? Good. What else? What? Auxiliary input. What else? Power source. That's it. That's the three ones that I chose. The three ones that I picked are those. But two of those don't comply with the third option. This is here. Network connection, no, because it's handled by the operating system. You can configure your computer to not accept connections unless you specify it, like taking out the automatic in the network connection. So you can use screen brightness or the display, of course, and you can use power input, but it won't be disruptive. It will be disruptive. Why? How is it a power source change can be disruptive? What happens if the laptop is out of battery? You unplug the cord and the computer dies. And then you have the disk encryption and game over. What happened with the screen? What happens if you have a default configured computer and you close the lid and you change the brightness? Because that's the only way to change the brightness when the computer is locked. The only way to change anything from the computer, from the screen when the computer is locked, is by shutting it down, and then the monitor will go off. And if the computer is configured to hibernate or power down the computer, then you're screwed. You close the lid, and then game over. So, what's the one that works? It has to be something that's available in every computer, that its execution, it's simple, that you don't have to start plugging things or connecting wires or opening the computer in half, that it's 100% hardware, that it's not checked or authorized by the operating system, and it doesn't care about anything, and it can do it if the computer is locked, and the operating system has no chance in fighting that hardware change. What? I don't understand. The what? The jack. Yes, the audio jack. You have a T-shirt. What? You have a T-shirt too. The audio jack. What is so great about the audio jack? Of course, it's available in every computer. All the computers that are here. I don't know about the new MacBook, that shitty one with the new USB. I have no idea if that has an audio jack. But before that, all computers had an audio jack for the headphones, not the microphone. We have the microphone integrated, but for the headphones, we have it. So it's on all computers. The audio jack has a mechanic detection. It's not about software. When you connect the jack, it's mechanic. The circuit is closed way before the operating system has a chance to stop it. And, of course, it works when the computer is locked. Check it yourself. Lock the computer with the music from the speakers, and then connect the headphones, and it will go to the headphones. No matter what you're doing, no matter if the computer is locked or there's no security feature that you can enable to stop that. So I have my hardware change. And on top of that, it notifies the operating system. So I have my trigger. So I have a hardware attack that is not suspicious. Oh, look, someone's connecting a headphone. Oh, my God. That the operating system cannot stop, but it will be informed of that change. And is there an antivirus that checks that? Is there someone here from an antivirus company that can say that they have a product that checks connection and disconnection from the auto jack? I didn't think so. So, again, 2 steps. We read that file, which includes all the information from the sound card. All the information relating to the sound card is reading and read all the time in that file, and it's pretty standard for all Linux distributions. The #0 means that the first sound card. If you have different sound cards, you will have different numbers. But the basic one is /proc/a sound card 0. And then, of course, check for changes. And then I'm going to do jack.py demo. And for that, I need a super important, badass hacker tool that I need you to borrow me for a while. Does anybody here have a headphone I can use? Just a simple headphone. Just to see that there's no trick. Okay, this one is bigger, so you can see it from behind. Thank you. I'm going to use this super amazing hacker tool to bypass X11 and backdoor my way into my computer. And I'm going to show it right now. Just a warning, when you start playing with this, your computer may be damaged. I damaged my computer playing with this. With all the plugging and unplugging, I kind of damaged it. So if you're going to play with this and you're going to try to replicate this, try to do it on an old computer that you're not in love with, like I'm in love with this one. So I'm going to show you this. First off, I'm going to do I'm going to put the codec 0. And they have all the information regarding to the sound card, like the internal mic boost volume. And it has all the information regarding that. Every control name is a different setting of my sound card. So we have speaker playback switch. We have a lot of things. We have a mixer. There's a lot of features on the sound card that we're not using. And of course, a better sound card will have better features. And you can read all this information to make your own applications that play around with the sound card. So the one that's important to me is the number 14, speaker playback switch. So I just did a small script that just reads and grabs that part and refreshes it. So it's doing that. It's grabbing that speaker playback switch. So I'm going to connect this and try to find the change. Someone see it? I'm going to try again. Did you see that? One more time. Here. The pin. The pin, regarding this pin, will change from 0 to 40. You see that? That's it. That's all I need. That's a small hardware change that is available to me, even if the computer is locked, and it doesn't care what the operating system says about that. The operating system hears and says, OK, and that's it. So, small problem, and this is for a T-shirt also. What if the victim wants to use the headphones? I cannot put the backdoor to say, OK, if the headphones are on, don't lock the computer or unlock it. What if the person goes to the bathroom and has the headphones on? The computer will never lock, and then we're screwed. Let's be creative. How do we solve this problem? A pattern. Yes, sir, you get a T-shirt. I only brought 3, sorry. I have a lot of stickers if you want to, but this is for answers. We create a pattern, of course. We create a simple pattern that sets checks every 1 second. For instance, you can put it to wherever. If you're faster with your finger, you can put it half a second. For me, for the demo to work, I prefer to do it each 1 second. So if you create a pattern that says 0, 1, 1, 1, 0, for instance, disconnected, connected, 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 disconnected, then you have the trigger. So we use dbus to unlock, and we have the super hacker tool, and then we have the special secret pattern that will only, of course, you can make it more complicated. You can put 0, 1, 1, 1, 0, 0, 0, 0. Of course, you can complicate it, but of course, that's not the case with the demo. I want to make it simple. And on a side note, the original pattern was 0, 1, 0, 1, 0, but after my computer broke, my jack broke, the computer would do alone 0, 1, 0, 1, 0, so the computer would unlock and ruin the demo for me. So be careful when you try this at home. So that's it. We set checks like 1 second, and we do 0, remember, 0, 1, 1, 1, 0, and that's it. Let's try it. No, don't go anywhere. So I'm going to do this, and then I'm going to lock the computer, and then I'm going to grab my super hacking tool, and I'm going to, let's count. 0, 1, 1, 1, 0. And it works. Since I don't have, I'm going to show you another one. Since I don't have anything set up for my, hold on. Since I don't have anything, I'm going to show you the other one with the screen. This one will unlock when I close and reopen my computer twice. So this is going to create some problems with the projector. It's going to pop back on. So I'm going to put it back. Then I have here 1. Let's go back. It goes up. That's it. So it's pretty nice. So how can you stop this? You can't. I'm sorry. You can remove dbus if you want to, but you will find yourself without any of the features that you're so used to be able to use on your computer, like shutting it down without using sudo or connecting to the Wi-Fi or whatever. So removing dbus is not nice. You can disable the lock screen If you disable the lock screen, you won't be able to lock your screen and you won't have screensaver. If you go away from your computer, you will have to manually close all applications and log out of your session and then re-log in when you come back. It's ugly, but it works. And you can switch to a minimal XDM, like XFCA or, well, I can't remember now, but all the minimal XDMs that you will find in Debian, GNOME, whatever, they don't have dbus integrated, and they handle all this in a different way. So do you have to run it beforehand? Of course. That's why it's called a backdoor. Can it be persistent? Of course. You can put it in the RC local, and that's it. How big is it? Well, my original one is 20 lines, but I'm very, I tend to use a lot of lines to write. You can put it in like 15 maybe. But of course, this is Python, and if you put a semicolon at the end, you can put it all in only one line and hide it wherever you want. If you have 10 seconds, you can backdoor any Python script or whatever you want with one line, and then you have a backdoor. What's so good about it? Of course, it doesn't have any opcodes, doesn't have any binaries, it's not compiled, it's not nothing. It's strictly Python. Everything runs on Python right now, so we're good. And it's virtually undetectable. You're going to have my email and Twitter account later. If you find a way to detect this with the current existing software, I've given this presentation in about 5 countries so far, and none of the antivirus in those countries had a clue even how to start checking for this without disrupting execution. Go to your computers right now, pop up terminal, open Python, and type import dbus. If it doesn't throw any errors, you are vulnerable right now. If it says that doesn't exist any module called dbus, then you're okay. If it says import dbus and that's it, you're vulnerable. Can you do it to root? Yes. You can do it to root. There's no way to stop root from being a victim of this. However, in default Linux distributions, root cannot lock the screen. This is a security feature brought by the X Display Manager, which is bundled with any Linux distribution. If you log in as root in your X session and you try to log your computer, you will not be able. So if by any chance you have a root user who has configured their session to be able to log, yes, you can do it to root. But there's no security feature that prohibits you from doing this to a root user. So you can't do it to root. Can you do it on Windows? Yes. You can use WinDbus, or you can use COM, RPC, or DDE, which are the similarities in Windows, and you can try to tamper them like I tampered with dbus. And of course, the last, can you shell shock it? Yes. Fuck yes. If you find a computer that is vulnerable to shell shock, you can remotely unlock it via CGI, SQL, or whatever you're using for shell shock. You just send the strings via the shell shock attack, and the computer will unlock. So yeah, I'm going to try to see if you can catch that and do it. So that's it. I'm done. Any questions? No questions? Wow. Either you understood everything or you didn't understand anything. Who has a T-shirt? You have a T-shirt? You have a T-shirt? Who else has a T-shirt? There's one more T-shirt. Sure.
Can I
yes, yeah. Great.
Can I ask my question?
Yes.
Okay.
Raise your hand so I can see you. Oh, great.
My question is very basic. Could I have a T-shirt too?
I only have 3.
Oh, just kidding. Thanks.
I can mail you one from Argentina, or you can come to the conference on November.
That's right.
A lot of people ask me if you can do this into Android. I haven't checked with all the distributions of Android, but yes, there are similarities into how Android handles this same calls and functions. So I'm not a big Android fan, so I haven't done it. But the basic Linux System calls are pretty similar, so if you investigate a little bit, I'm sure you'll be able to do it.
I have a question as well there about the USB
Yes.
and locking the computer. What do you do if you, for example, gonna lost your USB key or if it's gonna be stolen? So let's say you have it plugged into your laptop, you're going away for a moment for coffee, and somebody gonna steal not your laptop but your USB key and your laptop gets locked.
That's pretty fun. Well, you're the owner of the computer, so you can always boot live CD, disable the USB checker, and then reboot it. Or you can do a live CD, edit the Python file, and change the unique identifier to a new USB drive that you currently own, and that's it. You can fix it in 5 minutes. But it's a pretty fun situation when another one has the key to your computer. Yeah. Questions? No? Okay. Thank you very much.